Hello everyone, you are watching the 5.7 lesson video on factoring trinomials, day 3. So we are almost done with factoring trinomials, and you might think, what more could we possibly do with factoring trinomials for a third day? Well, let's dive right in to talk about it. So with example number 1, we're given the graph of f of x, and it says, graph it on your calculator, which I have already done, and we need to find its roots. If I look over here and if I went and did the menu and found my roots over here, I'm going to see that x is going to equal negative 1.5 and x is going to equal negative 0.5. So this is not good news, right? Because we have two decimal roots. And what we noticed before is that when we're given decimal roots versus integer roots, the integer roots really help us to factor. So right now, why is this slightly more complicated? We have both zeros, both roots are decimals. But that doesn't stop us. What does it tell us about the factors? Okay, well, let's think about this. Whenever they were nice integer roots, we were able to get nice integer factors like x plus 4 or x minus 7. So whenever we had those decimals, weren't we getting things like 2x plus 5? Okay, I'm just writing this as an example. I don't think this has anything to do with the question. It might, but I don't know. We would always have a number. So we would always have a number before the x. So this is what the decimal roots tell us, is that we're going to have a slightly more complicated factor. All right, well, let's use insight to factor. And then in our last step, we are going to go ahead and actually graph our answer that we get on the original problem. All right, so here's the deal. We have nothing to work with. We cannot put anything on the side just yet, but we can put in the 4x squared here. We can put in the plus 3, and we can say that both of those together have to combine to be a positive 8x. So right away, I'm looking at all my numbers. They're all positive, so it really wouldn't make sense at all to bring any subtraction or negative numbers into the mix, would it? So that's something that I'm thinking of right now. All right, we're going to use some mad math skills. First thing that I want to talk about, how in the world are we going to get these two factors? So this factor and this factor, right? We don't have these yet, but we need them. So how are we going to get them? Well, how am I going to get 3? What two numbers have to be multiplied together to get 3? Yeah, 3 and 1. And they both have to be positives. All right, we're on to something. One of them has to be plus 3 and the other one has to be plus 1. All right, here's the deal. You just told me above, or we just talked about above, that the number out in front of the x has to be something other than 1. So we can't have like 1x and 4x as these two numbers here. That won't make sense. So what other two numbers or what other two terms multiply to 4x squared? Yes, 2x and 2x. Remember, the 1x and the 4x would not make sense based on the reasoning that both of our factors have to have that number. In this case, oh, it is a 2. Oh my gosh. Oh, I was close. 2x plus 5. I had 2x plus 3. So wait a minute. This is my answer? That was amazing. So 2x plus 1 all times 2x plus 3. So if I was right, then I was going to get, what, 6x there and 2x there, and is 2x plus 6x 8x? Oh my goodness, this is amazing. So if we are to graph this on this graph here, so what? 2x plus 1, and then also 2x plus 3. They should be the same. Oh, this is magic. So we are now relying on the box method to both help us factor and check. It's like a 2-for-1 deal. I'm going to order that on the menu. All right, let's go on to the next page. Check it out. We are given 4 different trinomials here. So what I'd like for you to do at this point in time is graph all 4 of these on your calculator, and then we are going to touch base in just a moment to start having conversations about that. All right, so I graphed all of mine over here. And what I noticed was on every single one of my graphs, they didn't have any integer roots. So identifying the roots, I mean, it's great and all, but I'm just gonna make a general statement. They were all decimals. So we can't use them. I mean, we technically can, but we're not there yet. We might talk about this in Unit 6. For what we need to know now is that our decimal roots are not going to help us. So what we have to do is Plan B, which means let's set up a little box for every single one of these questions, because we know that our answers for all of these problems need to look like this. So I'm going to create my little factoring template or factored template or skeleton template. And then I am going to distribute to check, which is really helping me factor. All right, so here's the deal. Let's do the first one together again, like what we did on the first example. Number 1, we have 9x squared. We also have plus 8, and we have plus 18. All positive numbers. I'm digging this. I'm not going to bring any negatives in the mix because negatives can make things a lot more complicated. I'm going to think about the factors I have for 9. Let's see. Well, that's 1 and 9. So I could do 1x and 9x. But wait a minute. I can't, because when I graph this dude over here, they were both decimals. So what are other factors other than 1 and 9? Oh, yeah. 3 and 3? All right, let's do it. So 3x and 3x. Okay. And I need to get 8 somehow. And I'm going to get 8 from these two boxes that are left. Well, what about 1 and 8? So a positive 1 and a positive 8. Let's try it. Here I get 24x. Oh my gosh. 24x and 3x. That doesn't add to 18. Those are not my numbers. So why I just modeled that for you is I wanted to show you that sometimes we have to do some guessing and checking, and that's totally okay. So what are other numbers? 2 and 4 multiply? Let's see if those work. So 12x and 6x. I found my winner. 12x and 6x combines to 18x. We have our answer. 3x plus 4, 3x plus 2. I'm getting those factors from these sides here. Okay, so what I'd like for you to do on these questions 2, 3, and 4 is I'm going to pause the video, and I would like for you to, what do I want you to do? What can you do on your own? Why don't you see how far you can get with question number 2? All right, so with question number 2, you probably realized that some things were going on with this one. So you probably played around with this, and maybe you settled on the fact that 3x and 2x were there. But something that I want to point out, so with this particular question, these were correct, okay? So when you do this, you would end up with 3x and 2x, but we couldn't put a 4 here. And let's talk about why. Because 2 and 4 have a GCF. So we know that that 4 cannot go there, and it's going to have to go with my 3x. Sometimes you're going to have to play around with signs, like how I just realized, oh, that should be -3, shouldn't that? I can't talk and write at the same time. So when we actually multiply everything through, that's where we're getting our 8x and our 9x combining to be the -1x. So we have to do a lot of playing around with the numbers. So take a minute, pause the video, and work on 3 and 4. All right, so here is my work to questions 3 and 4. Something to identify in question number 4 was that I could not have, oh, don't yell at me. Okay, we got it. What we could not have was any x term. So what that meant to me was that this was a special one. My 36 and 25 both had to be the same number, but opposite signs.